yesterday I already touched about the SR latch and also what latch gate SR latch, isn't it? So yesterday also for section 02 and section 13 we already looked into the gate D latch, but today I'm going to uh review again and also do revisions on what we already learned on gate delay. For section 7, this gate delay still not yet touched. So here we're going to learn on it. So what happened under gate delay? As I remind all of you, please make sure keep and bear in your mind, just assume all these latches and also flip-flop just a normal logic gate, so you will feel like okay, it is easy, not too hard. If you see that, oh, what is this, it's so hard, so you will be having difficulty to get to understanding all these lectures and also flip-flop. So what's next is under get D latch, you can see over here normally you will be given only the logic symbol. As I already repeat in your class, you were given only logic symbols, but inside of this you are having the logic diagram circuit. So the D latch or gate D latch, you will see that this is the combinations of your SR latch and also your get SR latch over here. But when you add up another NOT gates over here, you will get D latch. So what is different is you have one input D and another input is your enables input. So here is the true tables of your D latch. It's very easy for you to remember because whenever your AND input is 0, nothing will be changed for your output. Although it mentions EN0, your latch is off, but your output not going to be 0. Your output will be look into your previous output latch for your previous output. So because you have the memory, so you need always look back to your previous output. So if your N is 0, any input D you're going to ignore because you just need to remain your output similar to your previous output, so no change at all. But when the EN inputs is 1, so you need to consider to look into your input D, but it's very easy to remember because it is always similar. So you just copy paste whatever input for your D when your N is 1. So this is the examples. You can go through over here all because it's just the descriptions about your D latch. So you can see there is two condition. First condition is D0. Therefore S0 R1. So which make Q is 0. And then D1, therefore S1 R0, which make the Q is 1. This is basically what happened inside your gate D. So this is what inside. So you need to know also what happened inside. But if you also remember this one for your get D latch is already okay. So this one is the example for your gate D latch. So you can see over here you have the input of D and you're going to look into your N only. So if you have the inputs N as 1, you will look into your what? Your input D. So whenever over here you will draw the dotted line like this. Then when you already draw the dotted line, you will refer your D. Okay, over here your D is 1. So you're going to copy it, paste. And in the question, you will notice that always you will be given the initial value of your Q output. So for your Q, which is output, going to give the initial normally. So over here you can see your initial starting as low. So although there is a changes over here at your output, you're going to be remain the same as it is no change, and only you will consider to change when your EN is 1, isn't it? So when your EN is 1, you will refer your D, and if it's 1, you will going to copy paste it to be 1 until your another EN 1. The remaining over here, when EN is 0, your output not going to be 0, but it always look back what the previous, which is remain the same or no change. Later you will look into over here, it is 0 and continue like this and etc. So this is the output. So you can also try by yourself. You can print screen this now and then try and draw your own Q timing diagram, what you're going to get. So I think the latches is very simple. It's quite similar to your logic gate, as I always remind you. Only the different when you are having EN input, and also another one is you're going to look your previous output, which is your memory. So now let's take a move to our flip-flop. As in our previous class yesterday, we already looked that there is 4 type of flip-flop: H trigger, D, SR, JK, and T for toggle. So over here, this is the picture listed of your H trigger flip-flop. So flip-flop is an important device in a sequential circuit. So normally you're going to have at least one flip-flop in your sequential circuit. So you can see over here there is 2 types, which is positive H trigger and also negative H. So what is the difference? This one is your clock. If you look back previously, I already show you the differentiation between flip-flop and also latches. For your flip-flop, you're going to be trigger, your output changes when your trigger your clock, isn't it? So that's one you already look into. So now this is the symbol for your clock, and this one is positive H and this one is negative H. Trigger flip-flop. So over here you can see that you have several example, which is SR flip-flop, this one is D flip-flop, and JK flip-flop. So you have SR flip-flop, D flip-flop, and also JK flip-flop under your H trigger flip-flop. This is the one. So you're going to have these 3 inside, which is SR, D, and also JK. So now let's take a look what happened after that. The difference between gate, latch, and also flip-flop clock. So what is the difference? Because you can see that clock and EN is quite similar, because a clock is basically when you are referring to flip-flop, and is referring to latches normally. and you already look into your N for your latches, and for your clock over here it is for your flip-flop. So what happened? You were given the Q for latch and Q for flip-flop. So now you can see you are having SR latches and SR flip-flop. So gate latch is activated by using level trigger in. So over here. But for FF, which is flip-flop, is activated by using H trigger clock. There is two conditions. This one we already looked into. Transition from 0 to 1 or 1 to 0, or from low to high or high to low, isn't it? Positive edge or negative edge, this one we already discussed in our previous class. Please look back your notes and module, so you can see. But under EN you're going to have only 0 and 1. So what happened for your latch over here? You're going to change the output when your N is 1, and the rest is remain the same. So you can see over here your latch, it will trigger when it start 1. You're going to check your latch SR. So when it is S and R, it's going to be set. So that's why you will put like this. Please make sure you refer your truth table for your SR latch. So if you still did not remember it, please make sure you try to remember, similar like what happened to your logic gates. And now you can see over here it will remain the same, and whenever over here happen, you will see that there is no change at all for your output. That's why you're going to move until here only first. So when you look into each one, you can see over here your 1 value is until up here. So what happened is, you can see there is a changes. For 1 over here, this one is 0, this one is 0. So for your set and reset, if it's 0, 0, it is remain the same, right? No change. So that's why you will draw until here. Then you can see you have 0, 1. For 0, 1, you're going to do a reset. Please check back, because I'm not also remember the SR latch tables. Please remember the truth tables. So if it's 0, 1, you're going to be reset. So it will come down, which is reset value 0. After that, you're going to be remain the same. No change, because your EN is 0, isn't it? And it will trigger back the N is 1. Over here you can see your input for your set is 0 and reset is 1. So you will do the reset. So reset is 0, so you will remain like this. So this is what happened to latch. So let's take a look into your flip-flop. What's going to be happen? So by default, as I mentioned, your clock for your flip-flop, you're going to pick the positive edge, which is positive whenever the clock change from low to high. So when it's here, you're going to trigger the value. So you will need what happened here. This one is 0, this one is 1. So 1, 0, you're going to set. It means that 1. So that's why you will do like this, and the rest will be remain the same, because you will trigger only at the clock. Okay, sorry, I continue. So you can see over here, after that you will remain the same until the next cycles of your clock, when it's moved from down to up, from 0 to 1, from low to high. So you need to check over here what is the value. It is 0, 0 over here. So 0, 0 over here, you will be remain the same, no change until your next clock. So over here you will see the value is 0, 1, 0, 1. It will be reset. So that's why you will get the output here. Please try to understand it, what is the difference between the age enables and clock. It's very important. So this one you can see level trigger edge, and which is for your enable latch, and another one is the edge trigger clock for your flip flop.